Hello guys, it's 3 a.m. in the morning now, and I can say that we're going to talk about plane geometry fundamentals, and uh, especially we're going to talk about points, lines, line segments, rays, and planes. So, first of all, what is a point? So, points in geometry is an exact location in space where it has zero size, length, width, or thickness. So, whenever you think of point, you think of, let's say, a dot, right? Like a certain dot. I can say this is point A. I can say this is point B. And I can say maybe this is point Z. And points, they're usually found in quadrants. If you know quadrants in linear inequalities, linear equations, and linear graphings, uh, those points are usually used there, especially in parabolas. If you know parabolas, well, especially people who are advanced in math, like points are also used there. And another example where a point can be used, the tip of the pencil. Pencils have like the tip of it, right? So the tip of the pencil has a point on it. So I can say this is point P for maybe pencil. But I'm just using that as an example. Don't copy this. This is point P. Wait, it should be capital. Let me change it. P. Capital P. That's capital P, guys. I can say this is the point of the pencil. Another example would be sorry for the interruption. So another example would be a specific location on a map. If you use maps, there's locations, right? Let's say this is the Philippines. This is the Philippines. I can say this is Manila, or point M for Manila. So that's 4 points. And moving on, we're going to talk about lines. So now we're going to talk about lines. So lines, a line is a straight or one-dimensional figure that has no width or line or depth. Basically, it extends in opposite directions. So whenever you think about lines, it's basically like this. And remember, naming lines, you need to have two capital letters. And the symbol for a line would be this. So whenever you see, let's say, like a line on top that has like two arrows on opposing directions, let's say BX, that's line BX, that means it's a line because there's a difference between line segment, rays, and so on and so forth. I can say this is line ZY, which is this line, okay? I can say that. And moving on, I'm going to show examples of where lines can be used. So there are multiple examples of uh, lines where we can use lines. Wait. Let me use my pen. So common examples of where lines can be used is the horizon. Let's say the horizon of the sky, where I can say the sky, say the sky and the earth meets. Okay, I can say that. I can say this is line AB, which is derived by this. Or I can say another one is a straight railway track, where if you see railways, trains, and so on and so forth. And another would be a laser beam that goes infinitely on both directions. And that's all for lines. And moving on, line segments. So now, line segments, the difference between a line and a line segment is that lines, they move or they are infinitely they're infinitely in both directions. So they go infinite in both directions. So the symbol for a line is this, but for a line segment has a starting point. I can say that S for a starting point and an ending point, or basically two distinct endpoints. So common examples of line segment would be a ruler. If you know rulers, they usually they're either short and they have ending points. I can say this is the ending point and this is the ending point and maybe this is another ending point and another ending point, and yeah, I can say this is XY and this is BD. So I can say that BD line BD line segment BD is congruent to XY line segment because they have the same distance uh, and they have the same length because they are a ruler. And that's all for line segments. Moving on. So array is a part of a line that has one fixed starting point. So a starting point and it goes infinitely and beyond. So I can say this is ray AB, ray AB. So the symbol for array is a one arrow that goes to the direction of it. So I cannot say it's ray BA because if I say it's ray BA, B should be here and A should be here, and it's an error. So this is wrong. This don't do this. I don't do that. And moving on, common examples of array are, let's say, arrows. If you know arrows, they have like this starting point, like they have like the tip and the starting point, basically the back. You pull the arrow, there's something you touch it, and that's the starting point, and the ending point is the tip. Or we can say an arrow in a bow, because once you pull this, it goes beyond infinitely, goes infinitely. And I could say sunlight rays, where rays coming from the sun, that could be one. Like it could be written like this, because it's really impossible for the sunlight rays to go back unless there's a mirror here that could bounce back, but that's a different topic. And another one would be a flashlight. If you know flashlights, they have a starting point and the ending point, basically the rays of the sunlight. So that's all for arrays. And also the symbol for array is this. Don't ever forget this. Like this, and BC. If you see this symbol, it's either going this side or this side, opposite directions. Only one arrow. Remember, for a line, it's two arrows in opposite direction, like this for lines, and for line segment, it's basically just a line, and for rays, it's like this. So we can move on to the next one. So a plane. So planes. So whenever you think of a plane, you know your notebooks, it has a shape, right? But a plane, it extends infinitely in all directions. And it has no thickness. So common examples of an plane is the surface of a calm lake. I can say this is a calm lake, right? I can say this is a plane because it extends into both directions. And I can say this is plane L. Plane L. This is a capital L. And maybe the floor of a very large auditorium. Like auditoriums, they're usually big. Oh, sorry. But like, yeah. And the surface of a smartphone screen. If you know smartphones, they're usually like a plane. It has no direction, it has no thickness, but it has lines, and yeah, it's and another one would be a sheet of a paper. And also, I forgot naming planes. Usually, it's just naming it by a capital letter. It can be A, B, C, and so on and so forth. But if there is non-collinear points, if there's three non-collinear points, let's say in the plane, let's say this is B, this is Z, this is H. So I can say this is plane B, Z, H, or Z, B, H, or H, B, Z, or so on and so forth. I can name it like that. But if there's only points, or if there is no points, we can just name it a single letter, like this one's capital letter all the time. Same rule for line segment, and race. It should be all capital letter. So now moving on to the practice questions. So first one is, which of the following is an undefined term in geometry that represents a specific location in a space? So remember, locations, there are usually points. And I can say it's C. So next, what is the name of the figure below? So remember, this is a line segment because it has a starting point and an ending point. So I can say this is line segment AB, or it can be congruent by BA, or line segment BA. And I can say it's letter C. Moving on, rays. What is the defining character of a ray? A ray has a starting point and it goes infinitely. Okay, it goes infinitely. And since that's the important factor that you have, important detail that you have, uh, B is the right answer because it only extends infinitely in one direction. Next, planes. Which of the following statements is true about planes? What I said earlier, it extends in all directions, and yeah, C is the right answer. Next, point M is the midpoint of AB. Let me visualize that. Segment. The given is a segment. AB. So I can say that, so the given is AM is equal to 7. So since AM is equal to 7, I can say that the answer of the value of AB is equal to the twice the value of AM, because uh, M is the midpoint. So I can say that AB is equal to 2 times 7 and is equal to 14. So that's the answer, 14 centimeters. Next, deliver the sample. Which of the following best models a line segment? A line segment has a starting and an ending point, basically two endpoints, right? So C is the right answer. Intersections. What is the intersection of two planes? So the intersection of a plane, whenever it is, I would say, colliding with another one. I can say, wait, this is a plane, right? That's wrong. Wait, let me write it like this. It creates a line. You see this part? It's a line. It creates a line whenever it intersects. So it creates a line B. So how many different rays can be named in the diagram below? Number 8. Uh, so since there's 3 points, I can say that x is going to xy. So it's equal to xy. Uh, y is going to x is equal to yx, and y is going to z, and I can say it's yz, and fourth, that would be x going to z. So I can say it's 4. So how many points are needed to name a line, and how many points are needed to name a plane? And I said earlier that a line, it should have two letters, or two points. So it can be like written like this or visualized like this. So A and B. So the possible symbol for this is this a line AB, and next for the plane is that planes you need at least 3 points for them. And ABC, I can name it ABC or plane ABC. So the answer would be 2 or B, sorry. True or false? A line can be a part of a plane. True. True. So a plane, right? It has lines. 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 Four sides, right? It is possible for a line because a line it extends in both directions, and a plane it extends in multiple directions, or it extends infinitely. So I can say it's true. So that's the answer. And thank you guys for watching this. I wish you learned something, and bye bye.